Hello and welcome, guys. Welcome to another interesting session of our DSA course. Today, what we are going to learn is analysis of algorithms. This is very important because this is literally the basic of our DSA syllabus, of our DSA course. And from here, you are going to learn how the DSA actually works. Okay? So, what is algorithm, guys? You must have seen whenever you do any programming, whenever you're doing any complicated programming as such, you basically need an algorithm, just a blueprint of how things are working. So that is what exactly an algorithm means. These are basically a set of rules to obtain the expected output from the given input. So you are going to give an input, and so based on a certain set of rules, you're going to get an output. So algorithm just shows the ways in which you are working. So from the algorithm, basically a flowchart is drawn which gives the overview of what functions or what functionalities your program is going to undertake. Cool? Next slide. What is algorithm analysis? You got to know what is an algorithm. Now let's see what is meant by an algorithm analysis. This is very important because the computational complexity theory, this is the gist. The algorithm analysis forms the gist of this theory. And what it does is, it provides theoretical estimation for the resources of an algorithm to solve a specific computational problem. So basically, when you're going to run a program now, you have to look at you basically need to predict, need to estimate that what are the number of resources it's going to require, and how much time it is gonna take. Is it worth it? It is worth it for the working of the project or not? So that can be undertaken by the algorithm analysis. Then why the analysis of algorithms is important? Because if you get to know that what are the number of resources required by a specific problem, you can predict the behavior of an algorithm without implementing it on a certain specific computer. So your resources are saved. Then it is practically impossible to predict the exact behavior of an algorithm because there are certain influencing factors. So you just get some not actual predicted value but nearby. More importantly, what does it do? By analyzing different algorithms, we can compare them to determine the best one for our purpose. That is, if we have, like, say, for a certain problem, we have 7 to 8 different algorithms. So, if we can, like, computationally evaluate, if you can predict that how much time, how much resources these algorithms are gonna take, you can just decide which is the best algorithm and you can work on that algorithm only. And by analyzing the different algorithms, we can compare them to determine the best one for our purpose. Got it? Then, what are the types of algorithm analysis? One is best case, worst case, and average case. So let's move to the asymptotic analysis. In our asymptotic analysis, what do is we evaluate the performance of an algorithm in terms of input size. This is very important. We are not going to measure the actual running time. We are going to evaluate the performance of an algorithm in the terms of its input size. That is, what is the input what you are providing to the algorithm. We calculate how the time or space taken by the algorithm increases with the input size. So if you are providing a certain input, then how does the time and the space complexity varies with respect to the input size? That goes under asymptotic analysis. Got it? Then what is the difference between asymptotic analysis and performance analysis, and why performance analysis is important? So, like, certain important factors are there which should be taken care of in the tech world. Like, is your system compatible? Is it user friendly? Does it have modularity feature? Security? What is the maintainability issue? The maintainability issues. So, why do you worry about performance? Because all the things which I told you before, like the user friendliness, the modularity, the security, and stuff, These things should be considered only if you have the performance. So these things are basically linked to the performance factor. So what is performance? It's like the currency through which you can buy all the above things. So the gist of all this is performance. And what is another reason for studying your performance? That is speed. And to summarize, if you tell what is performance in a single word, it is scaling. Speed factor. So just let's think we have given you a lot of theoretical knowledge. Now let's go to the practical implementation of it. Like I have given you two algorithms for a task. How do you find out which one is better? A layman. What is naive way? Naive way is a layman terms. The layman terminologies. What a common man will do, who has literally zero knowledge in coding, zero knowledge in technology. So what will the layman do? That person will implement both the algorithms and run the two different programs on the computer for different input and see which one takes less time. That is possible, right? But there are multiple problems which we will encounter. What is it? It is possible that for some input range, the first algorithm performs better, and for the second, some other algorithm performs better. This is very possible because you never know. See, if you draw a graph for the two algorithms, the time is to input graph, you will see that it's not a straight line, it will fluctuate. And the second possibility is that for some inputs, the first algorithm performs better on one machine, the second better works better on another machine. That is also possible. So, how do you like, if this is a problem, like how do you come out of this problem? How do you solve this problem? Okay, now let's understand the problem a bit better. For example, let us consider the search problem in a sorted array. What is a search problem? You have a number, say array. You have an array of 10 numbers, and I'll give you a particular number to search. Like suppose I have given you a sorted array like 1, 2, 3, 4, 5, 6 up to 10, and I tell you let's search for the number 5 and tell me in which position it is. Understood the problem? So there are two ways in which you can search. One is linear search. That is the order of growth is linear. We will see what does the order of growth means in the upcoming lectures. And a binary search. As the name suggests, binary search is dividing the array into two parts and then search. So the order of growth is logarithmic, the binary search. So first what we do, we run the linear search on a fast computer A and binary search on a slow computer B. Then what we do, we pick the constant values for the two computers so that it tells us exactly how long it takes for the given machine to perform the search in seconds. So we run a particular section on suppose computer A and we run the same problem with another algorithm on computer B. So the constant for A that we get is say 0.2 and the constant of B what we get is 1000. What does this mean? That A is 5000 times more powerful than B. For small values of input size n, the fast computer may take less size. Suppose the input, so you are thinking right now, I know what you're thinking is, like the A is 5000 times more powerful than me. But don't forget, my friends, I have given you that the array size is 10. I told you that I have given a limited input size. So that thing you should be in your mind that it's for a limited array length. If I increase the array length to say lakhs, so maybe the running time on B is much faster. You never know. That is written in the second point. For small values of input array size n, the fast computer may take less time. But after a certain value of input size, the binary search will start taking less time compared to the linear search, even though the binary search is being run on a slow machine. Even if the binary search algorithm is being run on a slow machine, it takes less amount of time compared to linear search if the input array size will increase. So which is the more efficient algorithm? That is the binary search. Maybe for small problems it may take a large time, the performance may be low, but when you increase the input size, the binary search is much more efficient than the linear search. I hope you get the importance of DSA. While you run a code, while you're going to companies, while you're giving interviews of companies, the online assessment of companies, there is a certain time limit which you should not cross. So that's why it's important. Optimizing the code. So does asymptotic analysis always work? You must be thinking that, is it what it always works? Are our predictions always true? Yeah, asymptotic analysis may not be perfect, but until today, it's the best way available for analyzing your algorithms. For example, we can take an example that there are two sorting algorithms. What is sorting algorithm? It means you are putting the numbers in either ascending or descending order. Okay, just arranging the numbers in ascending or descending order depending on the question. So suppose one algorithm takes 1000 n log n time and one more takes 2 n log n time. So both of these algorithms are asymptotically the same because they take n log n, the constant we basically ignore. So the order of growth is n log n. So with asymptotic analysis, we cannot judge which one is better because we ignore the constants.